Hi, hello everyone. My plan for this video was to actually do kind of free camera, maybe moving camera a bit. But then I realized when I added first 3D objects that we don't have depth testing, and I'm going to explain what depth testing is. We just have to first create a case for it, and then we can work on our test. And for this video, I have just prepared some materials, so you're probably going to need this texture, and I'm going to leave it in the description of the video. Just be sure to check it out, and then you can edit. And I have just added it to assets. It's called like this, but you can rename it to whatever you want. We're going to need it a bit later for our example. And so our goal for now is just instead of having this simple quad, we want to have rotating cube for it. So let's get started with that. So the idea why do we have cube is so that we can see this issue with the depth, and this will be the topic for the video. But first, let's try just to have some other object on the screen instead of that quad. And here we're just going to create a new simple folder called geometry, and I'm going to call this, I'm going to create a small class called geometry as well within it. So it can be public, and I'm just going to get rid of namespace so that we avoid collisions. And then this will be very simple class. The idea behind this class is it's just going to provide us with our vertex index data, etc. So if we go to our scene, right here we were creating this manually, but now this data is going to be provided by our geometry class. So we're going to have the use short, right? And this will be indices. And then we're going to have vertices, but I'm not going to call them just vertices. I'm going to call them interleaved. So that we know what does interleaved means. It means instead of just packing X, Y, and Z into it, we're actually going to pack RGB and UV into it as well. And then this, I don't think we're going to use it even. We can provide that information. For our purposes, it's going to be 0, because if you remember, if we do vertex drawing, let's see here, if we just draw with the vertex, we need the vertex count, right? Otherwise we need indices count. So we can just leave it at 0. And if you want to specifically add the vertices and vertex only, and to use vertex only buffer without indices, you can do that. I don't want to do that in this video. So next class is going to be our geometry builder. And here, so I will leave also this in the description of the video, because I don't want to type this whole class of geometry builder. I'm just going to copy it. And then you can see that we have quad geometry. And this vertex count is actually not important here. It's actually 4, but we're not going to use it. We're just going to leave it here. But we have quad geometry, right? And we have our indices and interleaved vertices. And then I have created cube geometry. And well, that's it. So don't type all of this. It's very error prone, and it's really not necessary. Just copy it over from the GitHub, and then you can have this class. And once again, I'm just going to get rid of that namespace here. Okay, so going forward. So just to explain this cube, if someone is not sure how it works, but basically we had our quad, right? And quad was made of vertex 1, vertex 0, 2, and then 3, right? And for cube, right, it was made of 2 triangles, but it had 4 vertices, right? And then indices were here repeating, right? We had 0, 1, 2 maybe, sorry, not here 2, actually here 2, and then we maybe had something like 3, 4, 5. It's not super relevant. Anyway, the idea is for the cube we can do same as here, but then we just extend it, right? So we have this, we might have something like this, right? With this being triangle 1, triangle 2, 3, 4, 5, 6, and then the sizes, the size that we don't see. And here we have front face, right? And here are the indices for the front, same for the back, etc. So just a reminder, just wanted to clarify and to explain how this works. Going a bit further, we can make use of it, and I'm just going to get into, and here I wanted to create, let me just see what I called it. I think I called it simple cube test scene. My name is not super relevant. Right? And for the cube test scene, I'm just going to be lazy, copy paste this, and then we can modify it a bit. Right over here, we're going to rename this cube test scene. And then we have to modify something else, right? So here we're going to actually create our geometry. So we're going to have geometry, cube geometry, and it's going to come from this class that we had, which is geometry builder, right? And then we can use create cube geometry, right? And instead of this array, we can just paste cube geometry dot interleaved vertices, and then we could paste vertex count. It's not relevant, and it's not correct, right? So this vertex count is valid, it will be valid only if we were drawing with vertices only, but we're using indices as well, so it's not really relevant. You might as well paste 0 here. I won't, but you can. And I'm just going to add a comment. We draw indices. So just for you that you know this, and then we can just resolve this using silver math. And I think that's all that we need. We just need to change it in our program. And here we can use cube test scene. And I'm going to make it first so that it loads immediately. Right? And if I try to run it now, it's actually not even that bad. But you can see some problems with it. And if I don't use the texture, right? So let's just do this so that it's clear what's happening. So instead of using texture in our cube test scene, I'm just going to uncomment it for now, right? And then it's going to appear all white because the colors are all white. So in our geometry builder, and you don't have to do this, I'm just going to do this so that we have something. So I'm just going to change some colors here, right? And I think that might be even enough, like, to see the issues. And you can see the issues, right? It's rotating and some sides are fine, but here it's all broken. And that's because we don't have depth testing enabled, right? What happens is, for example, the back face might be drawn actually after the front face and it's overwriting the front face, right? And that's what's happening here. And that's just because we don't have depth testing. And what depth testing is, it's just additional texture where we write our depth information. So just to explain it real quickly. So how does this work? Well, basically we're just going to have the texture which is same size as our screen, and in that texture we're just going to use, right, that information, and we're going to have some values between 0 and 1, right? And what we're going to do is we're going to clear our buffer to 1. So all of this will be white, right? This will be fully white texture. Why? Because it's all 1. And then when we have something, then, right, so the Z might map some over here, let's say, for one side, but for other side it might map over here, right? And then, because we have this depth comparison, right? If it's closer to us, we write to it. If it's further, we ignore it. So let's imagine actually this case as well. So let's say that we have our depth buffer 1, 0, and our pixel comes somewhere here at some point 0.3. and then we have something at 0.7. But since we're doing depth testing and this is actually further away, right? It's greater than 0.3, right? Being closer to 1, we just ignore it and it's not drawn. Therefore 0.3 or whatever the closer is to us or to camera, so to say, is going to be drawn, while everything that's further away is not going to be drawn. And it's actually just represented as texture, which is going to have like black to white kind of brightness type of colors, right? Ranging from black to white, and that's it. And we're going to see that in action as well. But first of all, let's start with that texture. So it's very simple, and all of this is basically setting up depth testing, right? So we're just going to need special kind of texture, I believe, but we're not going to even create a texture here because we can just handle it directly in our renderer, right? So that means that in our engine we're going to have additional texture right over here where classes are. So we're going to have texture, which is going to be called depth texture. And here I think we have some namespace collision, do we? Cannot find texture. I'm fairly certain, so we can probably do this. So I'm just going to say WebGPU texture. All right. I think there's some namespace collision, so I'm just going to use that. And then, so basically this is just alias for the texture from this namespace. And then we're going to have texture view for it, and we're just going to call it depth texture. So we have to create that depth texture. So let me see my notes. This will be very simple, but we're going to do it in this utility class that we already had, texture util. So here, right over here, I can just say public texture, right? Create depth texture. So the information here, we're just going to need basically our engine so that we can fetch device and the WebGPU API from it, and then we're going to have width and height, and this will be the same as our render texture basically. But here what I want to have is let's see, we're just going to need texture. I cannot type today apparently. Texture descriptor. And here we just have need to provide some information. Sample count is 1. That's not even relevant here. We would use it for multi-sampling, but here it's really not relevant. MIP level count is not relevant as well. We can just set it to 1. Dimension is still 2D. Size is right our extent, width, height, and then 1. Format. Now this is important because we might want to use stencil buffer in future. We're just going to leave it at 8. I'm not going to cover stencil buffer for now, but it's usually used just for masking part of the screens. We could have used something like depth32 float as well to use all of our bytes for depth, but let's just use this one. So depth24 plus stencil 8, and then usage. Here the suggestion is wrong. We're not going to use it as copy source. We're going to just use it as render attachment, and then we can just create it. Right, we're going to use our API, device create texture, and this is very straightforward. And then we're going to need texture view as well. So here, what do we need to change? Actually, the only thing that we need is this texture format. So I'm just going to do this. Texture format, let's make it nullable and set it to null. It's optional. So if we have our texture format, we use texture format. If not, right, this is if it's null, we're going to use the format from the engine. So we can just paste this format and that's it. Very simple. So let's just see if this broke something. I believe it has because of this texture format. So here, if anything is broken, you can just put label here and it will work. And now we just need to create that. So looking at my notes here, how did I do it? I think, yeah, we're just going to have a new private method somewhere below, right over here. Private void configure stencil texture. And here, I'm just going to do this as a precaution, right? If our depth texture view is not null, we can just release texture view, and then we can also do the same for depth texture. Why am I doing this before we have even created it? Right, in future, what might happen is we might support resizing of the screen, and we would want to have that. So we're going to probably need to recreate this depth texture. So it's just for that, right? When resizing screen, we need to dispose of once and once, right? And then here we can create it finally. So it's just going to be our WebGPU fill texture. So we already have this information, right? We just pass our engine itself in, and then the size, and then the texture view. It's very similar. So just here we need to paste format in. So this is a bit weird because I have hard-coded format in this, and here I'm using it like this, but yeah, let's leave it for now. It's not that relevant. Chances of us changing this format are, I guess, very low, to say the least. Yeah, that's kind of it, almost, right? We're not there yet. So in our engine, we need to configure that depth attachment. And where did I create color attachment? We have it here. So I'm just going to say here depth attachment. So we have this depth stencil attachment, right? And then we can just set a bunch of properties here. Depth clear value, what did I mention? We're going to have 0.1, right? So the closer stuff appears to us, the lower value it will have, ranging from 0 to 1. So range from 0 to 1. We start at 1, right? And then when we write something, it might have value like 0.5, 0.2, 0.3, maybe even 0. If it's super close. Yeah. Then depth load up. We want to clear it on new frame. Store up. We want to store all of our information. Stencil clear value is 0 for now, and if we cover stencil, we're going to cover all of this as well. And then we just need to paste that view in, right? And then here in the path descriptor, depth stencil attachment, just make sure to paste pointer to it, right? Does it have count by any chance? Depth stencil? No, it's all good. It's just one object. So you might think, okay, that's all well and good, but if you try to run it now, we get an error. And it doesn't say what the error is, not quite yet. So let's see, maybe I got it here. So it will say something like, let's see. Okay, first of all, I never called configure depth stencil texture, so that's one error, definitely. And now it will say validation error, render pipeline targets are incompatible with render paths, depth stencil attachment, which means we need to configure our render pipeline as well for this depth stencil test. So let's do that right now. So let's go to our pipeline, but we haven't created it here. We actually use render pipeline util. So now here we have to configure a bunch of stuff. It's not that hard. We just need to pass, let me see, depth stencil. So right over here we hit color, fragment state, and then we can say here depth stencil state. So we're going to have this, we're just going to need this stencil face state, but we're not going to use it quite yet. I'm not sure why you did pointer here. This is very simple struct. And here I don't think this will be relevant, so let's just fill it in with some port values. I think these are good. I'm just going to use increment clamp. Let's not worry about depth, about stencil for now. Like I mentioned, we're going to worry about it in the future. But here we can now create depth stencil state, and here we can say format, right? We already used this format. This format depth 24 plus stencil 8. Okay. Then we're going to have to pass bias. This is 0, no bias. Slope scale, not relevant here. Depth. Now this depth compare function is very relevant. So we want to write to it when our value, right? Our value in Z buffer is less or equal to some value. So what does that mean? So let me just try to find my drawing. So what we wanna do is, right, we have this depth buffer, which is from 0 to 1. Let's say that we have some 0 of 0.5. So if our new value is less or equal, then let's say that we're testing against some 0.5 value that was already written in the buffer, we're going to write the buffer, right? If it's less or equal, so if it's 0.5 or anything less, we write to buffer, right? Less or equal. But if it's greater, we ignore it and we don't write anything. So it means, right, at the beginning, our state of our buffer is 1. And let's say that we have some value 0.7. We write to it, right, because it's less than. But then the next value is 0.8. We don't write this into a buffer because we already have 0.7, right? And everything that's slower will be written to that buffer. Okay. So that's quite clear what this depth compare does. And then we're going to need, what am I going to need? Yeah, I just need to paste the stencil front. Stencil front. And then stencil back as well. Like I mentioned, it's not super relevant. And here in the scriptor, we can just paste this depth stencil state in, right? It just has to be pointed to it. Make sure to use here end sign. And if I try to run it now, it's still all wrong, which is not good. Let's see, maybe I did something wrong while configuring it. Let me check. All right, one important property that I completely forgot is that stencil write enabled. Obviously, we need to enable it as well. And now it's all right. So these are our colors, right? Yeah, and now there is no overdrawing of colors or anything. So that's perfect. So let's just do this small change. Let me just correct these ones. I want to have all ones. And then what I want to do is in our cube, I want to enable this texture again, right? And now it appears correct. There is no weird overdrawing, right? So the back face sometimes visible, sometimes not, but it's quite alright. I don't want to get into that. I think we might have something to do with, let me see, calling. I'm just going to call back always. Let's see if it works still. Yeah, it just appeared weird because we didn't call back face. Now it's alright. We could see it through through our, well, basically because we have some alpha values here. But anyway, let's use this texture that I got. So let me just see. It's set to not copy. Let's just set it to copy if newer, and I can use that. I need this, and then in our assets, this create. File not found. Not create, create. And here we go. We have our cube. So one thing that I want to showcase is just how this depth buffer looks into our tools. So in our tools, if I try to run it now and capture the frame, I just wanted to showcase this, what I was talking about. If we take a look at texture viewer outputs, can I check the depth texture? Let me just read that real quick. Here it is, right? As you can see here, I found the depth texture, and as you can see, we have white regions, and then this region is bit darker. And why is that? Right, because we cleared our buffer to 1. So our texture, when cleared to 1, is essentially all white, right? And then when we write to it, some values are lower than 1, and therefore they will appear shaded. If they were very close, they would be very black, right? We would just have a black color, or no color at all. So that's how this works. Just wanted to showcase this. And then what I wanted to do is just recap this, right? So what we did is, regarding the depth texture, so we first of all need to create our depth textures, right? And then the depth texture view, you just need to configure it. Very easy. You just create it as normal texture. Only difference is, right, the format and the usage. The usage is just render attachment. We don't need it in shaders, so therefore it can be just render attachment. Then we create the view. We just need to provide format. Very simple, very easy. Then we just need to configure it when we begin render pass, right? It's just this small part of code. It's not that complicated, right? We clear it to basically white color, right? Then we want to clear it on the new frame, store the values, stencil we can ignore for now, these are just defaults, and then we paste the view as well. And then what we had is, in our render pipeline util, we just needed to configure it for the pipeline. So unlike OpenGL, where you can configure this more or less like a global state, here you need to configure it per pipeline. And then we just configured it for the pipeline as well. Format, depth bias, so comparison function, very important here. Stencil state, not super important, and then we just have to enable it as well, and then paste it in right here. And that's it. That's how you can do depth testing. So hopefully you enjoyed this video. Next time what I want to do is camera movement. That was planned for this video, but as I was testing this, I wanted to have cube, and then I noticed, okay, we haven't configured depth testing, so that's why we did it in this video. Anyway, if you like this video, maybe like, subscribe, leave a comment, and until next time.